All right, everyone. We have the camera rolling, so I can work this. What you see before you right here is a problem with a capacitor that has two different dielectrics in it. The problem is asking for the voltage at the center of the two dielectrics. So let's read the problem. It says the figure shows a cross-section of a parallel plate capacitor with a plate separation of D. So the distance between both plates is D. The volume between the plates contains two slabs of dielectric with equal thickness of D over 2. So the dielectric is splitting the plate in half. Okay, let's put it down here where it should be. All right. And we have dielectric constant K1 equals 2. So this is equal to 2. And this one's equal to 4. Okay. And we have a 12-volt battery, and the picture already shows that, connected across the capacitors. And we want to know what the potential is between the two dielectrics. In other words, at this point right here in the center, what is the voltage? Okay. Now, we have Q equals CV. All right. And when you take a look at that, we can rewrite C, because remember C is K epsilon naught A over D. Okay. So we can factor the K out of that. So we could write C new equals K times C general. And if I take this here and I solve this for voltage, I can get voltage equals Q over C. Okay? And if I do what I'm doing here, I can write voltage as Q over KC. So these C's will be constant between the two voltages between the two dielectrics, because the C is for the overall thing. Okay? Now what I'm trying to do is I'm trying to write V1 plus V2 equals 12 volts. And the reason for that is the voltage across the capacitor is 12 volts. So the voltage up here and the voltage here, when we go across, have to add up to the 12 volts the battery is supplying. Okay? And that makes a lot of sense. And we've got an equation for the voltage here. So if I can find some sort of way of relating this, and I could write V1 equals Q over 2C, and V2 equals Q over 4C, right? Or 2V1C is equal to Q, and 4V2C is equal to Q. Well, the charges have to be equal, so I can now set this equal. 2V1C equals 4V2C. The capacitance is equal, because of the material property. So 2V1 equals 4V2, or V1 equals 2V2. And we have this equation over here, V1 plus V2 equals 12. Okay? So we can put this in place of V1 here. So 2V2 plus V2 equals 12, 3V2 equals 12, V2 equals 4. So the voltage, and we're asking for what is the potential interference between the two dielectric slabs? Well, we know this right here is 4 volts. Okay? And with that right there, we get V2 equals 4 volts. So our answer is 4 volts. All right? It's not really that bad. It's a lot like some of the problems we did earlier. Okay? There you go. There's a whole problem worked out. I didn't realize the camera was zoomed in quite that much. This is a new camera setup for me. One that lets me flip over to me over here from up there with pushing buttons, and I'm recording everything by pushing a button. All right. Thank you, everyone. I hope you found that helpful.